In this video on the basic synthesizer architecture, we're going to talk about other types of synthesis. We've spent 5, 6, 7 videos just discussing one type of synthesis, which is subtractive synthesis, where we start with rich waveforms and we use filters, a variety of filters, low pass, high pass, band pass, and notch filters to remove some of the frequencies and alter or change the sounds. We also talked about modulating certain parameters or parts of the synthesizer with LFOs, and we talked about adding envelopes, the most common of which is an attack, decay, sustain, release, or ADSR envelope. In this video, we're just going to discuss real briefly a few other types of synthesis other than subtractive. I'm sure that you realize by now that there are many forms of synthesis, and they all treat the art of synthesis in a different way. They use different parameters and values and techniques to craft or create a sound. We've spent some time discussing subtractive synthesis. Subtractive synthesis is probably the most popular form of analog synthesis. There are other forms of analog synthesis, though, as well. One of the others that is very popular is called additive. Now, you remember subtractive synthesis, we started with waveforms that are created by an oscillator, and then we used filters to filter the sound and craft it and change it, and then we also used envelopes. Additive synthesis is a little different. It adds multiple oscillators or multiple waveforms together to create a sound. Now, it also could use elements of subtractive, so you could have a synthesizer that had some additive elements, added multiple waveforms together, but also used filters and envelopes. The more you get into synthesis, the more you'll find that new synthesizers that are developed, and most all of them are virtual synthesizers, they're not hardware-based anymore, they're all inside of our computer, like the ones I've been showing you on prior videos. Nearly all of those use a variety of different synthesis techniques, including subtractive, as tools to create their sound. I mentioned that additive synthesis is a way of adding multiple waveforms together. So let's look at an example of that. Though this isn't really a synthesizer, I have a B3 organ here. It kind of represents a form of analog synthesis, additive analog synthesis. So as I add additional oscillators or frequencies, I'm adding to the sound. So that helps you to understand the basic concept behind additive synthesis. One of the advancements in synthesis was the first digital synthesizers, all digital synthesizers. The one digital synth that became the most famous and notorious for its sound was created in the 1980s by a company called Yamaha, and it was the Yamaha DX7. It was really the first largely successful digital synthesizer. One thing about all digital synthesis is that it does have a lot of characteristics to its counterpart, digital recording. Remember back in our discussion in Module 3 about analog and digital recording, we talked about the characteristics of analog and the characteristics of digital. We mentioned that analog recording was a little warmer because of the distortion. smoother, that kind of thing, fatter sounding. Well, that's really true of analog synthesis as well. We also mentioned that digital recording was real clean, real crisp, clear. You might say cutting. Some people even thought that digital sounded harsh. So these are the characteristics of digital, and these are the characteristics of analog. Well, the same kind of holds true for digital synthesis. So the DX7, though I don't have one, I have a digital representation or virtual instrument version of one that I can play for you. So as soon as I play this, you'll immediately recognize the sound of the instrument as well as the cleanness. So, you're familiar with these kind of sounds. Okay, that's a stereotypical Rhodes piano emulation patch from a DX7. In this case, a virtual emulation of a DX7. Any of the sounds that you get out of these synths tend to sound pretty clean, clear. Okay, so they have a lot of those characteristics, real clean, real crisp, no distortion, and those are very common characteristics found in digital recording. So analog synths tend to be a little warmer, fatter, rounder. Digital synths tend to be a little more clean, crisp, clear, maybe even on the harsh side. So those are two of the types of synthesis that I wanted to bring to your attention. Analog with subtractive and additive, and digital synthesis. One of the most widely used forms of synthesis today is called sample-based synthesis. And it's different from some of the other forms of synthesis that we have discussed and will discuss because it actually uses samples of real recordings as part of its sound generating engine. Instead of having an oscillator that creates a waveform, instead of that oscillator, it uses an actual sample of a real recording. So you can imagine that this type of synthesis process can give you really accurate replications of real instruments or real players, and it does. If we wanted to sample or create a virtual instrument version of a piano sound, how might we do that? How would we go about using real samples of the piano to help us create a realistic piano sound? Well, the first thing we might want to do is start with a reasonable amount of velocities. So we'd go over to the piano, we'd strike the key real softly and hold it down for as long as it's sustained. And that would give us our first velocity. And then we might go and hit the piano a second time and get a second velocity that was just a slightly louder. And we would continue this until we got sufficient velocities that we felt would replicate or represent the sound of our piano. Now, in the early days of sampling, as you can imagine, this type of sample-based synthesis required a lot of memory, a lot of RAM, and a lot of hard drive space. Companies who are very progressive, like Giga Studio, originally was called Giga Sampler, came out with the first sampler that could actually stream all of these samples off of your hard drive in real time. If you wanted to create a sound of a piano, you only had enough memory in your computer to maybe have one or two velocities of your piano to create your piano sound. And that's really not sufficient velocities to make a realistic sounding piano. By being able to stream some of these samples off of the hard drive and not have them loaded into RAM, they were able to do more of this kind of thing, where they could access more and more samples by streaming them in real time off of the hard drive. And this was really revolutionary at the time. If we are going to use 10 samples, say, to realistically replicate the sound of our piano, we probably should sample every single note. So now we have 10 samples, and we're going to multiply that times 88 keys. So that'll give us 880 samples. Now some of the pianists might go, well, wait a minute, that only covers one sound of the piano. The piano can create multiple different kinds of sounds. So this isn't a very good representation of the piano. And you would be right. There are other things that the piano can do that we're not representing here. So for example, the sustain pedal. When you hold the sustain pedal down on a piano, all of the strings are allowed to ring when one key is struck. So we would also want 10 velocities of each note with the sustain pedal down, because that's a different sound. So now we're going to multiply this times 2. So now we have 1700 samples. Also, there is the sound that's created when you hit the keyboard very hard. So you're also going to have maybe a staccato sound. There may be a release sound. When you press on a key and hold it down for a short period of time and then release the key, when you release that key, a hammer or a damper comes down on the string and dampens the string. Well, that's a unique sound, and you can hear that oftentimes in recordings. So we would want to also get the release sounds. So we'd want the release sounds as well. So another time, 2 times that, that's roughly 3,500, and then another 2 for the release samples. So that's 7,000. So you can see rapidly, as soon as you start adding this, the size of this synthesizer grows exponentially. It's not uncommon to have a sample-based virtual instrument that has tens of thousands of samples in it to create one instrument. The last form of synthesis that I wanted to talk about today is called granular synthesis. Granular synthesis is a fairly new form of synthesis, and essentially what the process is it takes a sample and chops it up into little bits and reorders it. In the case of this sound I have here, I've got just a sample of a sine wave. And if I turn on granular synthesis in this particular synth and turn the smoothing up, which will basically put some crossfades on all these grains so you don't hear how abrupt they are, when I turn up the intensity, you'll hear the sound start to change. Now if I get rid of the smoothing or the crossfades, it becomes much more apparent what's happening. So that is granular synthesis. That's one example of it. The ability to chop up a sample of a recording into thousands, if not tens of thousands, of little bits and reorder and alter some of their individual data. Thanks for watching all these tutorials. I know this has been a long section, but it's actually a lot of fun to learn about this material.